Hello everyone, thank you for taking part in this session. LF Energy has launched a project named Hyphae this February as an open source project for Microgrid. In this session, you will learn the vision of the project, what we have now, and what is the first step for the vision. I'm Kotaro Jinushi from Open Energy System from Sony Computer Science Laboratory, 100% subsidiary of Sony Group Corporation. We have worked for about 10 years to develop the distributed energy system. I'm also a tentative chair of a Hyphae project. Let me share my screen. Okay. Yeah. Here we go. Hyphae is a word web in Greek. We have a vision that future grid will not be a current monolithic system, but a set of rather loosely connected microgrid. Each microgrid has distributed energy, storages, and loads. They exchange energy information and energy over the existing infrastructure to take a balance of demand and supply of electricity. Without central control, we are inspired by the tree and fungi network which exchange information and energy in a forest, like a web. This is the reason why we named this project as Hyphae. Let me touch on what we have now for the project. From 2014 to 2020, we have worked with a university in Okinawa whose name is Okinawa Institute of Science and Technology Graduate University. We started a mutual collaboration to find a way to increase self-sufficient ratio of renewable energy inside the community, because at the time we believed that soon each house had a PV and battery and generated necessary energy by themselves. The distributed environment will be there. At that time, when we started the feasibility study, electricity is delivered from Okinawa Electric Power Company over their private grid. We install a DC microgrid over this AC grid to connect each house and exchange energy. We have installed 2.8 or 4.2 kilowatt PV panel and 4.8 kilowatt battery in each house. We also changed the priority of energy consumption, not from AC but from PV first, then battery, then energy sharing between batteries. If all the battery runs short of, they will take the energy from AC. And we use the existing AC appliance converting this energy to AC. Here is the result of feasibility and the simulation. On your left, this is a graph of actual result. Blue line is a with sharing and dot line is without sharing. And the gap, the improvement from the without sharing to with sharing of the self-sufficient ratio is something like 6% to 7%. And on your right, you see the simulation numbers. As you may know, that 2.8 kilowatt or 4.2 kilowatt will be small for a house who consumes 13 kilowatt hour per day. Upper graph in a simulation, if the PV size is 7.5 kilowatt and 10 kilowatt. Brown bar stands for without energy sharing case and the blue bar for with energy sharing case. To achieve self-sufficiency at 80%, you will need 13 kilowatt of battery without energy sharing and 11 kilowatt batteries with energy sharing. The gap is about 20%. When it comes to 90% self-sufficient ratio, the gap will become much bigger, and we can reduce the storage size by half. This will be a huge gap. Within the community, if we want to reach higher renewable energy consumption with smaller battery, energy sharing is the key, the simulation tells us. To realize this, we have developed two technologies. One is the physical, and the other is the software. This slide shows the physical side. We call the physical peer-to-peer energy sharing. On our DC grid consists with a DC converter, battery, and the DC grid itself. And usually the voltage of the grid sets zero. When the energy sharing starts, the voltage is set as a 35 volt constantly. The system controller sets the converter as a constant current mode for the discharge side. And the charge side will receive the same level of current from the grid. In these slides, N4 sent electricity to N1 and N3 sent to N5. As you see, 1 to 1, multiple 1 to 1, or 1 to many, or many to 1. You can configure as long as the capacity of grid allows. The other technology is now autonomous and distributed energy sharing software installed on each node. Each node can be a system controller called a grid master. This software periodically checks the SOC of the battery and consults the we call a scenario file. The scenario file has a condition when to send the discharge request or charge request. In this slide, these nodes run short battery so that they need to send the discharge request from others. Once the other receive the request, checking the SOC and the scenario and send back their conditions. And the requester decides, selects the sellers, and send the information to grid master, and grid master control the availability, check the availability of grid, and initiates the energy exchange between nodes. Here is the architecture of the core software APIS. The software runs on IoT boards such as Raspberry Pi or BeagleBone and with Linux. It is a Java-based software utilizing Vertex and Hazelcast for distributed computing. And on top of the APIS, we develop several modules to monitor the activities. We have a two modes of monitoring. One is a local one, and the other is a cloud-based one. All the software and documentation is available from GitHub.com or Hyphae. I have touched on the software we have for the Hyphae project. Based on such software, we would like to start our activity towards this vision. Here is the first step for the vision. As I told, what we have now for the set of software for DC microgrid. This can be used for specific installations such as a new development of the apartment complex or a gated community, because this needs additional installation of DC grid over the AC grid. But current majority is AC grid. Therefore, we are considering to apply the software to AC grid with utilizing AC-DC inverter with constant current mode to realize a similar function as DC. Since the supply and demand will be met, the energy sharing itself will not affect on the voltage or frequency of the distribution network. This is a key. This means that you can increase the renewable energy installation under grid constraint situation as well as the reverse flow from home to the grid. Control the reverse flow from home to the grid. To realize this, we need support not only for software, but also hardware side. Any support will be highly appreciated. Exciting? Should you have any interest, please contact the Hyphae TSC or contact me directly. Thank you for your participation. And any questions? Oh, thank you for taking the questions. And then if you have any questions, please feel free to ask. And myself and also the project leader, Daisuke Kawamoto, will answer your questions. Thank you.
Kotaro, there is a question on the QA, QA box, yeah. Who would you like to see join the TSC? Oh, there are some questions.
I can't find it. Events. Q&A.
Q&A, yes.
Yeah. What part of your product suite is? I think, we have, so that's our current, our module is to a distributed model, so that the software, basically it's a software, and the software runs on the IoT board. And also, we have several modules runs on the server side, which get information from each module and present to the operator. And also, operator can send kind of some parameters to update the software or to update the scenarios. And all the softwares are open sourced, and you can get it at our GitHub, Hyphae. Does that answer your question? But the question is ask a question. Yeah. Any other questions?
Some new questions. Can't you see? Why so much Java and thank you? Can this platform be applied as real-time microgrid control? What microgrid applications?
Why so much? Can this platform be applied as a real-time microgrid control? What microgrid applies are available in the source? I think, yeah. Why so much Java? I think at that time when we started the development, Java is we are considering to implement various devices, not only to IoT board but also to some inverters or some other form of devices. That's one of the reasons we selected Java's, because at that time Java is the very popular for a multi-platform. For the multi-platform software, that's one of the reasons why we selected about Java. And since the software itself is a distributed way, we select the framework which runs on the Java, like Hazelcast and also Vertex, and apply their time. I think we have not tested to work with the microgrid controllers, but we are happy to do that if some hardware vendors will help us. Then what is the main difference between the project and the other project like Bolton? Sorry, I'm not familiar with Bolton and Firewall. So what we have patented and also open sourced was to control the to transact the deal automatically over the DC grid, and we will check that those two projects, and then if we find the difference, and we will post that that to our the blog or some ways. I think, yeah. As firstly, we'd like to expect the people from the software side to expand our software, and also we are very much welcome the hardware vendor will join, especially for the inverter or the converter, the vendor from the inverter or converter, and also the batteries, because our system is how to manage the SOC between batteries, so that the battery vendor BMS vendor is BEMS vendor is key for this system. So we are welcome. Anything to add, Hamu-san?
That's good. Yeah.
ボルトン、いや、
ボルト。
ボルトン、ファイヤー。これちょっとボルトン。ナショナルナンバー。スモールスケールコンテンツ活動。へえ。Yeah, it's based on the user needs. Yeah, it's interesting. I'm not sure that the Bolton, in case of Bolton, that how they manage, because I just reached at the first page, but I think one of our benefit of the system, the user will not take care of the what's going on in the battery side. Once the scenario is described, when the user sets the conditions, when to discharge and when to charge, the system can transact that energy sharing automatically and distributed way. I think that's one of the difference, I suppose. It's great to know that there, a lot of activity in the world, and we are very excited to see that, to work with such the researches which has already done. Any other questions? I think yeah, in terms of fireware, I think we are very much focused on specific points, and actually what we are exchange is we are not much focused on the energy itself, and especially the energy stored inside the batteries. So I think fireware is a more wider concept to manage the the IoT, the distributed information, I suppose. What is the biggest challenge this project is facing? Yeah, I think one of the big at that time when we started, this project, one of the DC, environment. But that these days, so that's one of the biggest. I think the variety of the devices to support. We need, the more people to join to support for the various, devices such as converters and also such as inverters and also the batteries. Those how to develop the device drivers to manage such devices is one of the our challenge now. That's one of the reasons why we ask that many hardware developer to join and test or implement our softwares. To discuss how to implement our softwares and expand that system. Well, when it comes to open source microgrid controllers, also in another project inside LF Energy, we have a LIAPS, and the apps can build the microgrid controllers or work with some existing microgrid controllers, if I remember correctly. Now.
How long should we keep this session?
I'm not sure. So, can I ask that what is the interesting point of our presentation, and what kind of benefit you have find during the presentations? May I ask? By the way, why my video is turned off? So, I think the time already have passed 7. That you may. So, that's all.どうすればいいのかな。本当に、カモさんどうすればいいんでしょうね。これ、もうリーブしちゃっていいのかな。なんか質問もないですよね。あれカモさんミュートになってますね。
I think time is over, so
Yeah.
We should finish this session.
Yeah. Okay, so.
And if I think Lindsay write some link to the TSC on the chat.
Yeah.
So if any additional question, it's good.
Yeah,
to,
please send it. I think there's a trouble. I'm not sure. I think we can't input the 2-byte code in this, but this is interesting. So that we are leaving. Thank you for your taking part in this session. And should you have any further questions, please contact me directly. Myself and Daisuke will answer to your questions. And also, if you have any, idea about for the contribution, that would be really appreciated. Thank you. Thank you for taking the time for listening to us. Have a good day and enjoy the show.
Thank you. See you.